So today I wanted to talk about the 5 practical steps to improve developer experience. Because one day, I was, I guess, surfing the web or like looking at my RSS feed, and I came across of this blog post from one of the respected web service company in Japan. So I think the 40 million ARR company, which is a sizable, probably like a few hundred people, and I'd imagine maybe half of them are engineers. They are running this HR accounting SaaS for small businesses. So I guess maybe like a think of QuickBook Online kind of thing, right? And then this engineering team clearly already had a bunch of fair amount of automated test suites. And so as far as I can tell, the practices, are reasonable, like which is common in this like a tech startups, right? Like if you go to, I don't know, like maybe Union Pacific Railroad, you probably know. I'm not expecting like a cutting edge software development practices, but if you're going to a company that's been only around for 5 years, entirely built around the tech, the standard is pretty high here. So there sounded like it. So they got all the delivery pipeline done, automated test suite, pull request, the testing that's happening before the pull request, and they build a green, all of that set up on Circle CI, not on Jenkins, but that's fine with me. So on the, in a glance from afar where I stand, it looked like things are going great, right? But in this post, they tell the story that, well, it's actually like, what is their next challenge as far as they saw? They felt that the pre-merge testing is starting to take too long. And in their case, that's 30 minutes after parallelizing in the 16 way. So the test workload, I think collectively is testing, I don't know, must be like a 6-7 hour worth of testing, but like a spread in 16 different worker nodes, completing in 30 minutes. And I'm assuming he didn't tell me about this, but I'm assuming the company is heading for IPO or something. So, there's the order from the higher, like a marching order from the business saying, well, the cost is going up too high, in particular across the board, but in terms of engineering, those are the services they use to run and develop the software. And then they need to cut that. So normally this is kind of like a painful situations, right? Like, all the things they're using, all the services you rely on, maybe AWS or maybe Circle CI or, Jira or whatever, it's there for a reason. So if somebody tells you, like, if the bean counters tell you, well, you got to cut the cost, like, you kind of, they roll your eyes. So what they did that I thought was beautiful was that they decided to use this as an opportunity to reduce the time of the testing in ways that's actually more advantageous. So the way he framed the problem is, okay, when the tests are taking too long, like 30 minutes before pre-merge, what happens is it disincentivizes the smaller changes to be done. Right? So imagine like, oh, you want to make a small refactoring in this one code, or maybe the designer wanted to change the label of one of the web UI. Well, those are tiny, small changes. But collectively, when they add up to a meaningful amount of difference over time. But if every single one is taking so much computation, 30 minutes wait time, like a pull request approvals, like a complicated deploy process, then it just discourages people to do it. So that's the key argument of keeping the delivery pipeline nimble and agile, so that it encourages the developers to make changes, small changes quickly and move on. And obviously, like another side of it is, well, if the delivery pipeline is taking too long, then the urgent, important changes are also taking long and getting harder to be done. So that's resulting in like a longer lead time, or if the production has a fire, the mean time to recover, which is a metric to get the change fixed deployed into production, also suffers. Because it's usually this hot fix time that you don't want to cut the corners, and then you thought you put down the fire here only to like create another fire over there, which happens all the time. So that was the argument. So he took on the project to like comprehensively look at their automated test suites, and he was able to trim down the test execution cycle from 30 minutes to 10 minutes. So that's a tremendous improvement, right? And then they have done so without sacrificing quality. like it's obviously, well, quote unquote, easy to just throw away 2/3 of the entire test suite. Then obviously you can cut the execution time, but then your quality would suffer, right? So here the intelligent approach is necessary. And then he wrote this, he turned this into a blog post of 5 things they've done, which I thought was a wonderful story that I wanted to share, hence this webinar. All right, so the first one is deleting the slow. The first project they took on is deleting slow legacy tests. So so what do they mean by the legacy test? So basically he's drawing an analogy to the idea of the legacy code. And I'm sure if you're involved in the QA, you have some experience of this. There are some tests that's being inherited from who knows, like somebody who left the company 2 years ago. Right. And then you look at the test code, it's really not clear what it's testing. And sometimes these tests are really complicated. So just grokking it is an effort of its own. And often they are kind of kept alive because every time somebody breaks a test, they kind of want to keep the patch up the test just a little bit just enough to keep the test passing again. So when you look at the commit history, what you might see is some various people attempting to patch things up left and right and here and there to keep it going. So those are the symptoms of the legacy tests. So these are the tests of a kind of questionable value. And then if they are also slow in execution, then that creates a good candidate for removal, right? So like one example that they cite just to make this a little more concrete is that he focuses on this this suite of E2E parameterized integration test. So basically, like this test is doing like a send a request to the endpoint, and then get the which triggers the complex actions on the system side, and then get the response and make sure compare that response with what's expected, and if they line up, they pass. It's parameterized, so they have like lots of these request and response combinations. And then when he looked at the history, what you see is that this golden response image, like what the response should be, has simply been often updated by the current application behavior. So which I can totally see this happening, right? Like there's a request and response that's supposed to be like a one fine day, like you made a change in some like a little nice corner. And then you see this test break. Well, the expected result and the actual result are different. So what are you going to do? Like, are you going to spend time figuring out what's really going on, or are you just going to slap the current response back into the test and then make the test pass? Right. So that's what was happening. Or furthermore, like some of these parameters, like this request response combination, was simply skipped. And then because somebody, I guess they didn't even know what to do with the failure, so they just decided to comment on that. So those are like, and clearly all of these do feel like it's a symptom of legacy test. And then so what he did was, instead of just removing a test, because removing a test is a scary thing, and you need to get the buy-in from the team. So he verified. So he kind of goes on to the project to make the case for how to, why make a case for why it's okay to remove this test. So he ascertains that the newer functionalities are not tested by using this mechanism. So it's like all the combination really only came in from years ago. And then the past few years, the only thing that's happening is a cosmetic touch-up, like indentation change, the code formatting rules, the comment update, that sort of things. And he identified this other, if the newer tests are not done in this scheme, then what is the newer mechanism that these newer features are tested? And then he found that somebody invented a new layer of testing that's not this like an end-to-end integration test, but rather at the more finer grain level. And then people apparently, like developers apparently voted by their feet that they're testing this new functionality in that way. So that makes the case that, yeah, okay, this is probably not used very often. And then he tried removing this test, and so that the code coverage went down only by 0.2%. So he uses all these as an argument to kind of convince people that, okay, it's okay to remove this test. So that's what they did. So this is kind of fascinating, really, for me in many ways. I do like, and I'm kind of curious to hear your takes. I'm happy to, like, I'd love to hear your thoughts on the chat window or questions. But I do feel, and I have seen of my own eyes that, in my own eyes, that there are always some small number of like tests that take forever, and that's because most of us are really only looking at the aggregated execution time of the total test suite, and don't really pay enough attention to individual tests, right? Because like, to get the feel of, you kind of have a feel of how the entire test suite to turn around. Like you kind of know, everyone working in the team kind of know if it's 5 minutes or 30 minutes. But I bet that most people working in a team doesn't know which one of their tests is the longest running and how long it is. And I think they'd be more often than not surprised. So I think it's a great idea to focus on these small number of tests that's taking forever and then making a dent. But I'm also kind of curious, like, how would you make a case for removing the test? Like, clearly, like, he did a pretty thorough job here to making the case. But I mean, you could still argue, like, if somebody didn't want to argue, you could say, well, in these tests, it might be, while it might be true that it's costing some, the maintenance effort, they might be still covering these older functionality that hasn't been modified. So yeah, if while it's true that the newer tests are written in the different ways, but perhaps like by removing this test, you could do some legitimate coverage. So at the end of the day, I feel like really like this is people. I think people kind of made up what they want to do with this test. I bet most of the developers have already been fed up with this test. Like did this level of articulation help? Like did he actually convince some people and change their mind, or did he simply kind of gave them the excuse for people to say what they already felt? Right. So that's something I think about. Okay, so the second thing he drove was drive the awareness for the flaky test. So he was saying that in this previously, well, they have some flaky tests, which is not a surprise. I think we all do. But the developers simply just they're used to just rerunning these flaky tests until they pass and then get the green. Because remember, this is happening in pre-merge. And it's like his team, the team that's responsible for delivery pipeline, didn't have a good visibility into what's happening in pre-merge, right? Because people are simply running them. So instead, he was trying to change the culture by saying, well, if we see flaky failures, don't just rerun them. Like, give us a heads up so that at least we know. And then he makes the point of having his team work on some of these failures and fix them. So that to make sure that when people report the information, they get acted on, and it kind of set the bar high that the flaky tests are not tolerated in their environment. And there's also, he talks about in Circle CI, apparently there's a way to rerun a portion of the workflow instead of rerunning the whole thing, which makes the rerun a little bit faster. So those efforts, he said, led to a state where the flakiness is no longer a problem. So that's great for him. Like I have this one of all the things he did, I have a conflicting thoughts. The one is first, tracking flakiness in test suite, in test executions, to me feels like a machine job. Right? Like, what's the point of asking developers to report those in a Slack channel and rely on these anecdotes, right? Like, it's much better to kind of get the test results collected somewhere and then mathematically infer the information so that you can focus on ones that's creating outsized impact. I have an entire separate webinar. I think in the archive you can watch it if you want, where I talked about this, what our industry could actually pick on flakiness. So this is a topic that's close to my heart. The second thing is, in most places, I don't think eliminating flakiness is possible, nor a particularly good idea. It's like it's like keeping your house tidy, right? There's always some amount of chaos, and the more the closer you try to contain the chaos down to zero, then the incremental cost of doing so like goes up, but the return kind of goes down. So to me, the key mindset is to figure out the right level of the chaos that you tolerate, or right level of the flakiness that you tolerate. And speaking of the chaos in the room, you can see like my room is pretty chaotic. So I think this, well, I have a higher tolerance on that. But so, like he's trying to reduce the flakiness down to 0. Like apparently they succeeded, so kudos for them. But is that something the rest of us should try to imitate? I don't know. I'd love to hear your opinions on that. Okay, so the third thing they took on is what I call the test selections. The idea is, to only test what's needed. So in their case, they use a monorepo where both the front-end code and the back-end code lives in the same Git repositories. So previously, the way things were set up is, like when any change in the repository results in the entire test suite running, which turns into a lot of computation cycle for the cost program and also the longer feedback cycle. So what the idea here is like, okay, if you only change the front end, it's not necessary to run the back end testing because that's not going to get impacted, right? So he came up with this the mechanism, basically like a hodgepodge of shell scripts and like some Git command and figuring out what's being tested and some YAML file that defines, oh, the area change in this area should trigger this test suite and so on. And then so he came up with a few observations like, okay, like you wanna define this as a negative. So instead of saying, well, these changes result in this execution, you say if the changes are just here, don't run these tests. So it's a negative condition, so that as the repository structure evolves, you're always on the safe side. And like he makes a point that it's important to notify the developers when tests are skipped, so that they know, they are aware of it. So just in case this logic has a problem, then the engineers working on the change can catch it. So part of the shell script involves, like a GitHub API to post a comment on the PR saying this this test suite was removed and whatnot. So it's a little bit of a programming work that he took on, but so the result was, the skipping unnecessary tests, which obviously made things faster. So I do see in various teams that I saw that this incremental build execution and test execution is often untapped. And then that's kind of unfortunate, right? Because if you think about what's going on in the CI server, on one hand, like we generally prefer, there's like a trending period in time in which we focused on like clean isolation, meaning like what's happening in this pull request doesn't influence this other pull request, which kind of naturally results in everything gets rebuilt and retested all the time. But if the scale of activity is big, most of these things, test and builds that's happening are like a very similar, like say common libraries, like they might be the same. So if we can effectively reuse these builds and tests by figuring out the right dependencies, that gives you a tremendous boon. But unfortunately, like in reality, that the degree in which you can do these things is severely limited by your build tool and test runners, to the point that it's often like impractical. So it almost needs like a dedicated build tool like Bazel to do it. But as everybody knows, swapping the build tool from one to the other is just such a tremendous undertaking. I've shown up in BazelCon, and then people are talking about the migration that went on for years. It's not like like a 4 engineers, and I was horrified to hear that they had to spend that much effort. So I think the test selection is great. I mean, even his convoluted Git script and the script that involves Git, in comparison, looks very decent compared to like what some of these other guys had to do in terms of the amount of effort. But that is the challenge. Okay, so the fourth thing he took on is to work on the slow tests. So this was so there are a couple of ways he went about it. So, one common pattern he observes is like, the people, well, engineers often prefer to write assertions separately and then clearly documenting, okay, what this assertion is about, what aspect it is testing. But often and before they get to be able to make that assertion, they have to go through a lengthy setup, right? So, like a few of these records in the database and call these operations to set up. And then you make this one operation and then verify the result. You make the same, you invoke the same operation in a slightly different way, and then it checks the result that's slightly different. So if the setup is long, then this tends to be fairly time efficient, which is true. Okay, this is not a problem if you unit test and the whole thing is like, like a 100 millisecond. But if you're talking about, let's say, 30-second setup time until all the server starts up and database gets populated, and like a 1-second operation and 100 millisecond assertion, then you can start to see why it might make a lot more sense to actually combine these assertions from the time perspective. So that's one thing they took on. And the other thing is this, the typical test runner is designed so that the setup code is shareable. So if you have a tests that are slightly more different, but like nonetheless related, then it's easier for devs to write like a one setup code in that test class that does all the setup necessary for all the tests. And then so if you look at the individual test case, it's only using a part of the setup work that's done in here. So that is wasteful. So like he observes, for example, in one test, just one of these guys needed like a 200 records to be inserted into the database, when all the other tests only needed like 5. Right? So, but because it's more convenient, every single test was trying to create this 200 row mockup, and that was costing the time. And then so he pulled out that he created more like a nested structure of the setup, or maybe pulled it out into separate class. So basically eliminated that redundancy to get a significant time varying. Another common pattern that he observed is combinatorial explosion. So in some of the parameterized testing that you can do, like, you might say, okay, this is a different kind of database, and this is a different kind of like a request response pattern. And then you can create like those two axes multiply into like a big combination. So in this case, you got 7 by 7, so 49 combinations. But, is it really necessary to test all the combinations exhaustively? So so he sort of manually carved out, saying excluding some of the combinations that are redundant or low value, and then being able to reduce the combination down to some significant degree. And these are the kind of things that's like, if somebody is writing a test from scratch, you might think about these things, but over time, if like one person had this one axis, and then like a year later, somebody came in to add another axis. This complexity and its slowness could grow over time. So that's, I think, is the kind of key observations. This last bit is a little bit more Circle CI specific, I suppose. But so Circle CI, and also I guess I should say Jenkins also has this capability, but or the Launchable for that matter. Like a common practice to cut down the test execution time is like just parallelize, right? You have 1,000 tests, so let's split them up into 10 ways, like running each equal bucket size, and then you can in theory reduce the test execution time to 1/10. Now, this is this team already uses that. They use Circle CI, as I said, like a 16 parallel execution. And these different bars designate the time each test runner took. So, you can see like the longest one took 33 minutes, which are a lot longer than I guess, there are more entries. So this is not even shortest, but I think the top 10 was like a 13 minutes. So, that's a lot of like uneven parallel distributions. So in this case, he says the total test execution time was 200, this is idle time. So he said the total execution time was 272 minutes. So ideally, if you can completely divide them into equal bins, it's going to be done in 17, so somewhere here. But you see like the actual execution, the longest poll is almost twice that, 34 minutes. So what's happening is twofold, he says. The one is that the Sarkozy is apparently not great at creating even-sized spins, but also he makes the point that if some tests are taking long, like since then that sort of makes the job of creating equal bins difficult. And the unit of parallelization in case of Sarkozy is a file, and that is, there is always, I mean, that is actually true also with Launchable. But with Jenkins, we can do a little bit different things. But anyhow, the unit of parallelization tends to be often a little bigger. So if a single file contains 100 test cases, it's all taking a long time, then that, just dividing that up into multiple files kind of create this core, like a finer grained unit of test execution, test parallelization, and that helps. So he was able to kind of break things up, and just by doing that, they'd be able to bring down the wall clock turnaround time for the test execution. So those are the things. I think it all makes sense, like a common sense performance optimization. And then the last bit of particular performance optimization that he calls out is the common super common setup code. So and I think this is true in some test runners. But as the thing that gets tested more complex, then you do have this very complicated test setup logic, right? I remember writing one for Jenkins that they extract a zip file, places this into these directories, and download this here and there. So all sorts of like a one-time operation kind of gets over time crammed into this single setup code, and it starts to take a lot longer. And then he makes a point, well, this is happening for every single test case. So if there's one thing that is worth optimizing, then that would be this. And then so that's what he took on. And also in my personal experience, I do remember taking these things on as well. So that made sense. So he was able to, as I mentioned, take on these 5 projects and was able to trim down the 30 minutes down into 10. Which is just an amazing progress. Now, so I think the lesson that I think all of us need to take away from this story is we shouldn't be just collecting more tests, even though the first instinct is to collect more tests so that the quality is higher. Right? So it's actually equally important to keep the ones that matter, and then cut the fat away, so that you have more rooms for more tests, so that you have incentives to keep the test suite valuable as a whole. I know it's easier said than done because I've suffered my own share of this long test suite that's kind of over time gets unused. And I think the Maria Kondo made this speech in a different context in home. Right? You should learn to throw away things. Don't just collect stuff because it actually doesn't spark joy in your life. So I think it's a lesson that applies to us as well in the software development. The other thing is, okay, so this company was amazing that they were able to put this one very sophisticated guy to work on this project for months to impact this result. But let's face it, that's a luxury that not all of us can afford, right? And I feel the reason I started working on Launchable is because this kind of analysis and then keeping the tests that matter doesn't need to be done in different teams. I think they are reinventing the wheel. So we made Launchable in such a way that if you can send us a test result, then we will show you some of these insights like I mentioned, and then that helps you make the case for throwing the test away, or we can also automatically select the right meaningful subset of the test for you to execute without throwing them away. Right? So you're effectively not running them, but so it's almost as if you soft deleted them, but you don't have to go through this painful part of actually convincing people to delete them. So I think I'd like to think we are the developer experience team for the rest of us. If you can't afford a dedicated team in a company, then rest assured your problem is not unique to you, and I think a generic solution is available. So that's what I wanted to talk about here. by the way, there's also a blog post version of this on our website. So it's here. So I'm sure this link will go out in the follow-up email. But if you wanted to pass this around for other people in the team to get them thinking in this direction, there you go. I made a presentation in the area that matters. I appreciate the feedback one way or the other. But otherwise, thank you very much for joining me in this webinar, and have a wonderful rest of the day. Thank you, and bye-bye.